Hey friends, you might know that with Checkly's API checks, you can test and monitor all your API endpoints on a schedule and from around the globe. But not every API endpoint is the same. Some API endpoints might be a quick and easy GET request, whereas others might rely on dynamic data fetching beforehand and also need some custom validations on the response body. In this video, I want to show you how you can leverage setup and teardown scripts to get the most out of your API checks. Sounds good? Let's go. Let's start monitoring this API endpoint that is available at Checkly API Playground /API/prime. The idea of this API endpoint is to return a prime number. But as you see, when I call it and make a standard GET request, I get a 401 response telling me that I need to authorize first. So how could we get a prime number? When I go over to my terminal and I call this API endpoint with an authorization header that is bearer 123456, I receive successfully a prime number, which is 7 in this case, and that looks good to me. But I don't want to inject magic values in my API monitoring, but rather fetch this token from elsewhere. So where could we get it from? I also build up another API endpoint that is available at API token, and when we call this, we will find that here we have a token that we can inject into our HTTP request that is part of our monitoring. What I want to do is I want to fetch this token, I want to make this API request, and then afterwards I want to validate that this number or that the responded number is a real prime number. So how could we do this in Checkly? When we head over to my Checkly dashboard, you will see that I already have a prime number API check running. It is running every 10 minutes, and the API endpoint that I just showed you is tested from North Virginia, from Ireland, and everything is good to go. Let's rebuild this API check and include setup and teardown scripts to learn how these work. To create a new API check, you can always press this lovely blue button, create a new API check, and let's give it a name. I will sloppily call it rebuild for now. Then you have to define your HTTP method and the URL that you want to call. So let's copy our prime number API endpoint URL. Let's paste it in and let's run this request. So right now we receive the same results. Let's fix this, add the authorization header, and also add some proper assertions. We can close this modal, and when we now scroll down, what I want to do first is I want to add an assertion for proper status code of 200. And then I want to add the authorization header. So we can go here to the header section, and we can add a new HTTP header, and I know that's authorization. And I know that the token right now is bearer 123456. So when we now test this API check again, we should have a succeeding API check. And indeed, we have here a green light. But now we're dealing with this hard-coded authorization token. How can we make this dynamic? Above the header definition, you see that we can reference environment variables in the headers by using this curly braces notation. So we can go into our authorization header and we can change 123456 to use an environment variable that I will call API token. When we now go down, you will find that we can run setup and teardown scripts before and after our check one. So when we open up the editor and we set up a setup script, we can go in here and we can say process env API token equals, let's say 345. When we now run our API check again, we will have a failing API check, but hopefully we will see that we made our header configurable. And that's right. So now our API request was failing again, but when we look into the header section, we will find our authorization header that now includes the value that we just set in our setup script. So when we now go to our setup script and we replace this dummy value with a real setup script. So what I'm doing here is I'm importing Axios. I'm making this API call to the API token endpoint. I'm getting the token, and now I'm setting this particular token to the API token variable, which then will trickle down into the authorization header. So when we now run this request, we are all green again. And now whenever this token changes and when this API token endpoint receives a different token, this API check will still work. You might now wonder, okay, you're importing Axios here. Where's this coming from? So whenever something runs in Checkly, let it be a setup or teardown script or a browser check, you are using a Checkly runtime. So we pre-built these runtimes so that we don't have to run npm install, and it comes with a whole lot of dependencies that are ready for you to use. So whenever you want to script your browser checks or you set up a teardown script, it's always good to have an eye on the runtime definition to see what dependencies are available. So at this stage, we have an API check that dynamically fetches an API token from another API endpoint and injects it into the authorization header. The only thing missing now is to validate that the number that is responded from our prime endpoint is a real prime number. So how could we do this? When we scroll down, we'll find that Checkly API checks come with a whole lot of built-in assertions already. So if we wanted to check for this property of this JSON payload number, we could go in and we could say JSON body, and now we could get the number property and we could check a comparison here. And it ranges from equals to has key to has value, and there are a whole lot different options to add an assertion. But isPrime is not one of them. And in these cases, you can leverage a teardown script to check if the responses of your made API request is what it is supposed to be. So let's create a teardown script. When we scroll up again, we will find next to the setup script section that we already did. Remember, this setup script runs before the API request is made. And similar, there's also the teardown script section that runs after the request has been made. So what we now can do is we can parse the response body. So whenever you run a teardown script, there's a global variable that is called response. And we now go in and we say console log JSON response, and we run this API check again. We should see in the job log our prime number being returned. So here we see the response of the API call, but when we go to the job log, we now see here the parsed JSON response, which is pretty much this here coming from this API prime endpoint. So all we now have to do is we have to go into our teardown script and we can assign some logic. First, I will assign the JSON response to a variable. So let's get the number out of JSON response. And now I will paste a little helper function that I grabbed from the internet, so isPrime. And now what we can do is we can say if not isPrime, let's give it the number that we just have. We want to throw an error, which then will lead this API check to fail. So in this case, we will say throw new error. And we will tell it that this is no prime. When we now go up and we run this API check again, we should have a succeeding API check. Here we go. And let's just to confirm that it works and flip around the condition so that this API check will fail if there's a prime number. So let's run this again. And here we go. We will find our error. And even though this API request returned with the 200, this API check failed because we added some custom validations in our API check. So let's fix this very quickly again. Let's scroll down and let's create this API check. It will run a final time to see if it's succeeding. And now let's hit save. And with this, we just created a new API check that fetches an API token from a different API endpoint in a setup script. And it includes some custom validations in a teardown script to make sure that your API responses are what they're supposed to be. And this is how you can set up API checks in the Checkly UI. But of course, there's also another way to do it by leveraging monitoring as code. Let me show you quickly how I created this prime API check right from my repository and from the command line. When I go back to my editor, let's make the terminal a little bit smaller and we inspect the files, you see that this is a Checkly CLI project. It includes a Checkly config and it includes a prime check TS file. And guess what? All the configurations that we just saw in the Checkly UI are available as what we call them constructs. So we see here the URL, we see here the GET request, we see here our header that includes this environment variable and a setup and teardown script that live in different files here on my machine. And when I now go to the terminal, I can even run this API check right from my terminal. So when I run npx checkly test, this API check runs in the Checkly infrastructure and we now get a successful result and we have a properly set up API check with setup and teardown scripts that live in my repository. And if I wanted to make some changes to this API check, I can always go to my terminal and I can say npx checkly deploy to update the resources, to update my testing and monitoring infrastructure with a single command. So no matter if you create your API checks via the Checkly UI or via the Checkly CLI, setup and teardown scripts make your API checks much more powerful. If you want to learn more, you can always head to the docs, and here we have the setup and teardown scripts that explain in detail how you can set up custom headers in your setup scripts or how you can add some more custom validations in your teardown scripts. And on the left side, you see plenty examples that you can use and copy and paste into your setup and teardown scripts to get the most out of your API checks. And this was this week's Checkly tip. If you have any questions, drop them in the comments below. And if you want to join the Checkly community at checklyhq.com/Slack, we are a lovely bunch, I promise. And I will talk to you very, very soon again.